Next up, we have Morteza Ahmadi from Qidni Labs, based in San Francisco, California. Morteza, welcome to the stage. That is an amazing head of hair, my friend.
Thanks so much.
Good luck.
Thank you.
5 minutes starts now.
Okay. Good morning. There are over 650,000 patients in the United States with end-stage renal disease. When kidneys fail, the only option that patients have to use to survive is dialysis. Dialysis costs about $82,000 per patient per year, which adds up to a huge market size of over $50 billion per year in the US alone. Dialysis was invented by Dr. Kolff in 1943, but the technology hasn't changed much since then. Currently, patients have to go to dialysis clinics 3 times a week to remove uremic toxins and excess water from their blood. Unfortunately, this process is associated with very low survival rate of only 40% in 5 years. Several studies suggest that to improve survival rates, we need more frequent treatment. In other words, if we provide more than 3 times a week access to treatment, the patients may live longer. That's where we come in. We are building a miniature wearable device that replaces dialysis. Our device fits in the palm of your hand and provides significant improvement to the life of patients. In comparison with dialysis, our device weighs only 1 pound. It can be taken almost everywhere. It can be used by the patient themselves. And the device can be used as frequently as possible, and potentially it can be used continuously. We have tested our device in pig models at UCLA, and so far the results have been satisfactory in meeting our design requirements. In the next slide, I'm going to quickly show you a short video from that surgery in the operating room. We took out the kidneys from this animal, and this is the very first sample we collected with our device on the pig model. We work closely with UCLA, Stanford University, UCI in the United States, as well as Grand River Hospital and St. Joseph Healthcare in Canada. Our business model is based on renting our device for $50 per day to distribution channels. Distribution channels provide services to patients for free, and they'll get reimbursed by Medicare and Medicaid. With this business model, we can generate $1.8 million of revenue each year for every 100 patients. You can imagine with 10,000 patients, we can generate $180 million a year. We own 100% of the intellectual property related to this technology. We have 2 PCT applications and 3 provisional applications which covers the core technology behind this as well as the device. For regulatory, we are joining expedited access pathway at FDA, which helps us to commercialize the product faster. We work closely with FDA. In the next 2 years, we'll be completing studies in animal models, and then we'll start testing in 250 patients. On our team, myself, I have a PhD in biomedical engineering, and I've completed 2 years of fellowship at Kidney Foundation of Canada. My co-founder, she has a degree in management from University of Waterloo in Canada. In our team of 8, we have 4 PhDs and we have 2 masters. On our advisory board, we have key opinion leaders in surgery, in nephrology. We have chief of surgery from Stanford University on our board, and we have people who have brought many medical devices to market before. We're asking for $500,000, and we are using that money mainly to prove the function of the device in sheep models for 7 days with no kidney functions in those models. The main part of that money is going to be used to hire engineers locally and creating jobs in Buffalo. We expect at the time that we commercialize our product, we'll be producing about 100 units of kidney devices here. And with that, we're going to create more than 200 jobs in the manufacturing sector locally in Buffalo. In addition to that, we would love to work with nephrology department at University of Buffalo in the preclinical stage and clinical stage to bring our device to market. Thank you very much.
job. Okay, Morteza, for our judges, we have an amazing kidney transplant program here at UCMC Hospital. Okay, we'll kick it off as soon as we get to 10 minutes here. You finished early, which is impressive, considering your presentation was 40 minutes yesterday.
Yes.
All right.
He's right.
Okay, who wants to go first?
So artificial kidneys are certainly the holy grail, right? Can you explain, I know it's a long way away where there's going to actually be a product that a consumer can use, but what is your vision now as to kind of what it will look like, where they'll wear it, how they'll dispose of the content? I mean, just the sort of practical nature of what this product will look like.
Yes, of course, and we have prototypes and we have been testing it. So it's an external machine that's connected to the current vascular access that patients use. So this is a hemodialysis catheter that's connected right here, and these two ports are globally standard like USB. So as long as patients, any patients on planet, they're on dialysis, they get hooked up to dialysis machines, they can use our device. Our device is a super small miniaturized machine. It's externally used by the patients as frequent as they want. And because it's very light and they can carry it, it gives them a lot of freedom. They don't need to go to dialysis clinics anymore. So they can work, they can travel, and they have access to this all the time, basically. If they want to take a shower, they can remove it.
But it's not something they wear every day.
Microphone.
They wear it every day. They wear it every day. So that's where the benefit of this device. They don't need to go to dialysis clinics 3 times a week. But if they wear this every day, and because it's small, there's no problem with that. They can wear it most of the time. Because of that more frequent treatment is going to provide longer survival for them.
Yeah, I get that. Is there going to be a way to dispose of what comes out of the...
Yes, so there's a small bag of 250 milliliters attached to it. So you can imagine how many times we use restroom. They can use the same number of times to just replace that bag.
Next question. We got Darren, please.
Yes, could you talk about reimbursement? Do you plan to use an existing code, and how do you make money with that?
We are working with CMS on that. So we have had meetings with them. Currently what we know is that dialysis has been historically something that they reimburse. It is in the law, they have to reimburse it. It's one of the exceptions in the US health system that they have to reimburse. And so we're trying to find a model that fit within the same scenario without changing it. For example, they have this bundle model at the moment, and so we assume that, okay, so they provide 3 times a week dialysis and they reimburse for it. Now, the device that we have is just more frequent. And right now they have models for more frequent dialysis. So we believe that it can be a very good fit within the same model. But overall, when the kidneys fail, based on the law, they have to reimburse it.
Answer your question. Next. Martin, please.
$500,000 seems like such a small amount of money to be raising for a device like this. What do you think the total capital needs of the company are to bring this to market?
Absolutely. So this is just, let me see, does the presentation work still? Yeah, so this is a bridge round to another round that we are raising for $200 million, for $2 million. And that $2 million is to meet all the FDA requirements to start clinical studies. We have been speaking to many VCs and investors about that. We know by collecting the data for 7 days in animal models, we can collect this money. And this money will be used to extend the life of animal to up to about 30 days. That's the requirement by FDA. So this is the total number of studies that we have to do, and we have to complete in large animal models such as pigs, such as dogs, and such as sheep models to provide enough information to FDA to let us start testing in patients. And with that $2 million, we're going to get there, but based on our conversation with the investors, we know that we need this $500K to complete the 7-day study to get there. Overall, devices like this would require something in the range of $40 to $50 million to completely get commercialized.
Next question. Ross.
I believe you said it was going to be given free to the patient, and the people that were giving it free were paying you $100 or $50 a month. Is that correct?
A day.
A day.
$50 a day, yes.
So, what are the costs of putting this thing together? Are they reusable? Do you just toss them away? And how do you monitor whether or not they're being used correctly?
So the system transfers information for the usage. So we don't need to be worried about that. So we know we can know the usage of the device. And so that's how we monitor it. In terms of how long we can use it, so this system can be used for several weeks before it needs any change of nanofilters or anything else.
Next question, Johnny.
The filters, they're geometric in the profile, so they're capturing proteins and molecules by geometry, right? So you don't have any toxicity profile of what you're making the filter out of, is that correct?
We do. There are multiple stages. We mimic the filtration and reabsorption function of kidneys. So in the filtration part, kidneys retain a lot of proteins in blood, such as albumin. We do the same thing. So the albumin stays in blood, and this was confirmed in the animal study as well. Several uremic toxins, we know that the range of uremic toxins that we have in our body, the range of size of molecules starts from 50 Daltons up to about 40,000 Daltons. And those are the molecules that we focus on in the processing.
I don't know if you've looked at it. This may be very well suited for the FDA's pediatric profile for accelerating products.
Yes.
They're looking for products that can come in first as a pediatric and then to the adult.
Yes, absolutely.
You may want to look.
Our advisor in Stanford University, he is actually doing kidney surgeries, pediatric kidney surgery. So he has suggested the same thing, and it is a really good market as well, and we would love to help kids as well.
It's a great point, John. Accelerated path to approval. Next question. Go back to you.
Yep. So in your presentation, you mentioned building the product in Buffalo.
Yes.
So under your model, when would production start?
So we expect to commercialize the product in 4 to 5 years. So that would be the time that we start building, the centers to assemble the device and also manufacturing the core technology behind it. Even right now, the core technology behind us, which is a nanofiltration system, we searched for it, we couldn't find commercial product for it, so we built that in-house. We completely built that in-house. And in our previous interviews, I also mentioned that we would love to bring that part of manufacturing to Buffalo and build all those nanofilters here.
Next question. Got 2 minutes left. Joanne, please.
So the IP is around the nanofilters?
The IP is around two things. First, the core technology. Now, what is that? When we look at the kidney, in summary, how kidneys work is that we have a system of filtration that removes a lot of fluid in blood, and then a reabsorption mechanism to reabsorb a lot of that. So this is the mechanism. Any technology that would mimic this function of filtration and reabsorption related to kidney, we work on that and we put that together as a device. So our IP covers both this core technology as well as the device itself.
But much of the device is going to be like a pump and stuff like
A nanofiltration system.
Right, but there's going to be a little pump in there. These are
Yes.
things that you're just buying off the shelf.
Yes, exactly. The core technology behind us is that nanofiltration and reabsorption that other people don't have. And we have patents on how to manufacture those things.
We have time for one more question.
I would ask, who are the other big players in this space? And have you been in conversations with anyone, and would you consider joint venturing to accelerate this product to market?
Absolutely. So we have been in conversation with all of them. Fresenius, Baxter, DeVita in the United States, as well as Nipro and Nikisa in Japan. And we have been in conversation with all of them. We have been in contact with them. It's ongoing conversation. I can't disclose much information at the moment, but it's something that we have been talking about. Yes.
Johnny?
You
Quickly.
said that you have a patent.
It's submitted. It's not
You
complete.
don't have any issued IP.
Not issued yet.
Correct.
Yeah.
Do you have any office actions?
Pardon me?
You have any office actions on your IP?
Any office actions on your IP?
Say it again.
Office actions. Any commentary from the FDA at this point?
No, not yet.
Are you talking about IP or are we talking about FDA?
Well, the patent office, but yeah.
Patent.
Yeah, so on the
Okay.
patent, we got some results back. So a lot of the claims that we have are cleared.
Okay. Great job.
Thank you.